All right, welcome back. This is video number 3 on the lesson about the side angle side theorem. So really what we're going to do here in question 3 is kind of treat this as the given information. So angle EPF, which is this one right here, is congruent to angle GPH, which is right there, and P is the center of the circle. So even though this really isn't presented as a proof, I'm going to try to answer it as a proof. Okay. So let's go ahead and create our table. We're going to have the statements on the left and the reasons on the right. And then let's just go ahead and number it 1, 2, 3, and 4. So lines 1, 2, and 3 is going to be the statements about the side angle side pattern, or the side angle side pairs of congruent parts. And then number 4 is going to be the names of two triangles here congruent. So the two triangles, you can probably tell which ones they are. It's going to be this one right here, which I'll color yellow, EPF, and this triangle over here, which I'll color in orange. Okay. So let's start by, well, so we already know a pair of angles that are congruent. So I can fill that part in right here, right? Angle EPF, which is the one in the yellow triangle, is congruent to angle GPH, which is the one in the orange triangle. And we can just write given. Okay. All right. So all of our work really revolves around finding the pairs of congruent sides. Okay. Now, one thing to note is that we have a circle and P is the center, right? So any segment we draw from the center to the edge, or the circumference of the circle, is going to be a radius of the circle, and the radius of the circle is always the same, right? So I could say that the segment from P to H, that's a radius. The segment from P to E, that's a radius. So since they're both the radius of the circle, they're going to have the same length. Okay. I can say the same thing. The segment from P to G is also a radius, so it will have the same length as the other ones, and the segment PF is also a radius, so it will have the same length. So actually, any segment that starts at P and goes to the circumference of the circle, they're all going to be the same length. And so this is going to be our side angle side pattern. Side angle side pattern. So let's go ahead and say EP is congruent to HP. Okay, and the reason is because, well, they're both radii, or they're both radiuses of the circle. Okay, so the plural of radius is radii. Okay, so they're both radii. And then we can say that PF is congruent to PG. Again, both of those are radii of the circle. Okay. And radii are always congruent, or equal in length. Okay. So we've got that side angle side, side angle side. So now let's go ahead and name the triangles that are congruent. So I'll do EPF, triangle EPF, and HPG. Okay, and we're going to say the side angle side theorem, right, is what we used as evidence to make that claim. Okay, side angle side.